Welcome to Math Minders Academy. In this video, we provide solution to WAEC 2024 mathematics objective questions. We want to explain how best our learners can make use of our tutorial videos. For you to benefit greatly from this video, we implore you to first provide your solution. Just pause the video. When you get to a question, pause the video, provide your solution, then play the video to go through our own solution. Compare it with your solution, and where there are differences, you can use our solution as a guide to check through and make necessary corrections. By so doing, you'll be able to learn while watching and benefit greatly from the tutorial video. So, having said that, let's proceed now to the solutions. Let's go. Question number 21. We have a shape that is not drawn to scale. They said in the diagram, the line segment MN, that is this line segment here, is parallel to KL, which we can see, and then the line segment ML, and KL, KN intersect at S. So this middle point here. The length of the line segment MN is 12 centimeter. This length is 12 centimeter. The length of the line segment MS is 10 centimeter. And the length of the line segment KL is 9 centimeter. If the area of triangle MSN is 16 square centimeter, calculate the area of triangle LSK. Now, we want to do something to this diagram. We are going to see triangles, two triangles will be similar, but we need to mark them off. Now, let's look at these two lines, KL and MN, they are parallel. Now, this angle here, marked red, is going to be alternate to this. These two angles here are equal. Now, let's mark another angle. Now, let's come here and mark this angle here. This angle that we mark with, should we use pink? Maybe let's use a deeper color, let's use blue. Now, this angle marked with blue here, and this angle, they are also alternate. We call them Z angle, so they are alternate. Of course, this is the pattern when you have something like this. You have this angle here to be alternative. This line here and this line here are parallel. Now, we come again. Let's pick another color. Let's take green. This angle here and this angle here, they are equal. They are called vertically opposite angles. Now, it shows that, now let's name the two triangles that are similar. Now, triangle, if we take triangle MSN, let's take MSN, we say it is similar. This triangle MSN is similar. This triangle is similar to triangle. Now, when we pick M, look at M, that is the angle marked blue. If we go to this triangle, we are going to pick L. That's it. part that matches with L. Now look at S. In triangle MSN, this angle that we mark with green color matches with this. So we're also going to have S here. And then let's look at N. That's this red, and this curve will match. So we are going to have this. So these two triangles here, this triangle and this triangle, they are similar. Now, when two triangles are similar, the ratio of their corresponding length will be the same. Once you pick any of the corresponding length and put it in form of a ratio, they will be the same, irrespective of which corresponding length you are picking. Now, let us also remember that here, the ratio will form what we call the scale factor. So let's take the scale factor now. We call it SF, which is scale factor, the ratio of the corresponding side. Look at M, the side MS, and the side LS. They correspond, but of course, LS is not given. We don't have any dimension for LS. We don't have any dimension. Now, let's look at this KL is given, that is red to blue, red to blue. So now let's look at red to blue, that is KL, KL. Or if you come here now, last letter to first letter, KL, last to first. Come you here, you're going to take last to first. N, M. Now, if you look at it, that is going to give us KL is 9, and NN is 12. We can reduce this to 3/4. Now, this is the scale factor. Now, let us look at area factor. Area factor, we found area factor when we raise square factor to power 2. Raise this scale factor to power 2, that gives you area factor. Very good. Now, another way of getting area factor is by using the actual areas of the similar shapes and put them in ratio form. That means the actual area of these two similar triangles, if I put them in ratio form, they are going to be equal to this. Remember, 9 is from the small triangle, 16 is for the bigger one. So if I don't know the area of this smaller triangle, LSK, LSK. So let's call that area, let's call it Y. Okay, so we can say let Y be area of triangle LSK. Now, if we take this area over the area of the bigger triangle, which is given as 16, that will now give us the area factor. And this will be the same as this area factor that we already have here. It will be the same. Now, solving this will now result to, of course, you can cross multiply, or when you look at the denominators are the same. So this is like equivalent fraction. This is denominator 16, denominator 16. Definitely the numerator is going to be 9. Of course, you can still go on. If you cross multiply, the 16 will cancel out. Or you can say multiply both sides by 16 to clear the denominators. If you multiply both sides by 16, you're going to have y to be 9 centimeters square. 9 centimeters square. And that will be the actual area of triangle LSK. And if we go to the option, that gives us option B. We'll mark it. Hoping that you understand it very well, we proceed to question number 22. Question 22 says a ladder 15 meters long leans against a vertical pole, making an angle of 72 degrees with the horizontal. Calculate correct to 1 decimal place the distance between the foot of the ladder and the pole. So now this is the pole. This is the ground level. A ladder 15 meters leans against a vertical pole. So we are going to pick the ladder. This is the ladder that leans against this vertical pole. And don't forget, so this is going to form a triangle here. Now we are going to have right angle triangle because the pole is perpendicular to the ground. That's why it has to stand very well. So let's name this. This will be the base of the pole. This is the foot of the ladder, and this will be the top of the pole. Now we are told that this ladder is 15 meters long, and it makes an angle of 72 degrees. So the angle here is 72 degrees. So now we are asked to calculate correct 1 decimal place the distance between the foot of the pole, which is the distance from F to B. Let's call this distance Y. And now let's go and use SOHCAHTOA. Of course, I believe we should know how to use SOHCAHTOA. SOHCAHTOA, that is, we have the hypotenuse, all right? Of course, opposite is not given, so we can't use sine. We have the hypotenuse here also, and then the adjacent is given. So if you look at this, we have the hypotenuse given, the adjacent is given, so we can apply cosine. So we say here that cos 72 degrees is going to be adjacent over hypotenuse. So when you cross multiply, y is going to be 15 times cos 72 degrees. So you can go on and use your calculator to get the value there. When you multiply, you are going to get 4.635. So you get 4.635 meters. But they want us to leave it to 1 decimal place. So our final answer is going to be y equals 4.6 meters. And that is option D. That's option D. So with that, we proceed to question number 23. Question 23, we are told that in the diagram, O is the center of the circle. If the length of line OA is 25 centimeters and the length of the line segment AB, this is AB, which is the chord, is 40 centimeters. Find the length of the line segment OH. So OH is from O to this place. So let's draw that triangle. Let's draw the triangle. And then we have this. So this is O to H. And remember, this is perpendicular here. This is A. And then we have B. All right. So what other thing are we given? We are given 25 centimeter. Yeah. Good. Now, the line from the center of the circle that bisects the chord is actually perpendicular to it. So that this line OH is a perpendicular bisector, meaning that this part, that is AH, is equals to HB. So we are going to share this 40 into 2, and that gives us 20. So what that means is that we are going to have AH as 20 and HB as 20. Okay, so remember we are looking for OH, and so let's pick up one part of the triangle now. Okay, if we pick up this, and then we have this as 25, then we have this as 20, this is A, this is O, and this is H. And then we are looking for OH. That means let's call it X. That's height. It's actually what we are looking for. Now, again, we are going to two sides of a triangle, right angle triangle is given. So we are going to apply Pythagoras to find the top side. So Pythagoras says that the square of the hypotenuse, that is OA squared, is equals to AH squared plus OH squared. So using that, we are going to have 25 squared is equals to 20 squared plus X squared. All right. So going by that way, we have 625, that's 25 squared equals 400 plus X squared. All right. Now, if we proceed that way, we're going to have 625 minus 400 equals X squared. Of course, if we look at 625 minus 400, it's going to give us 225. So we have 225 equals X squared. If we take the square root of both sides, S is going to be square root of 225. And it will come out as 15. So S is actually 15 centimeters. So we write it here, 15 centimeters, and it's actually the length of the line segment OH. So the OH you are looking for is 15 centimeters, which is option A. So mark option A. I hope this is very clear. So we will proceed to question number 24. Question 24, given that E is 25 meters on a bearing of 330 degrees from Q, how far south of P is Q? So let's put our cardinal here. All right. So now, for the bearing, we start our reading from here. This is 90, 180, 270. We sweep it up and we proceed here. All right. So let's put a cardinal for the next point here. So they say, given that P is 25 meter on a bearing of 30 from Q. So this is where Q is. And of course, this is where P is. And this is 25 meters. And now they also remember that this is the north. This is the north of P, and this is the south of P. And then they say how far south of P is Q. So if we move Q this way, we move Q this way, we move, and then we will continue to project it towards the south of P. So these two lines will intersect and then give us a right angle triangle here. And so now we need to find out what is the size of this angle marked with white ink here. So what we'll do now, this is from here to this place, 90, 90, 90, 270. 270 plus what will give us 330. That's 270. So we'll say 330 minus 270. That gives us 60 degrees. So inside here, we are going to have 60 degrees. Now, we are looking for how far south of P is Q. Okay, how far south of P is Q. So what we are now looking for is this value here. Okay, that is what we are looking for. How far south of P. So is how far south of P is Q. So if we look at it, this is south of P. Now we need to get from here down, we will locate Q. So if we take SOHCAHTOA, let's pick SOHCAHTOA. This is sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Now, hypotenuse is given. So since hypotenuse is given, we cannot look at this. This is out. Now, we are looking for opposite, and hypotenuse is given. So we'll be considering this first one. So we are going to be using sine. And so we'll say sine 60 is equals to y all over 25. So when you cross multiply, y is 25 times sine 60. If we continue to solve, y is going to be, if you multiply sine 60 by 25, you are going to get 21.65 and some other numbers, of course. So you get 21.65. There are other numbers that will follow. But because we are going to, all the answers given here are given to one decimal place. So that's why I'm not considering the remaining numbers. The only number that we are fed 6 is 5. So I'll go on to write y equals 21.7 meters. And if you look at the option, you agree with me that B is the correct option. So with that, we proceed to question number 25. Of course, if you find value in this video, go ahead, subscribe to this channel, click on the notification bell so that when we release new video, you'll be among the first to get the update. Share this video so that other learners will have access to it. Like, go to the comment section, tell us what you love about this video, and let us know what area of this video you want us to improve on in our subsequent releases. Let's proceed now to question number 25. Question number 25 says a car valued at $600,000 depreciates by 10% each year. What will be the value of the car at the end of 2 years? Now, depreciation, what happens is I can get my multiplier here. I can get my multiplier by subtracting 10% from 100%, and that gives me 90%, which is 0.9. That's my multiplier. So I'm going to decrease this 600,000 by this multiplier 0.9 within a period of 2 years. And if you do that, that will give you $486,000. So this method is very short. Of course, there is another way. Some students might choose to do it step by step. Probably they'll depreciate year 1, subtract 10% of 600 from 600, so you get a reduced amount. They proceed to year 2, take 10% off from that amount that's already reduced. That will bring us to 486,000.00. So that's also another method. But you know what I normally tell students, especially when it comes to objective, always look out for the shortest possible method, because in examination, you are working against time. So you need to improve on your speed. You need to learn techniques that will reduce the steps necessary or required to produce results to a particular question. So you need to develop your skill and learn how to manage time. So this is the shortest possible method that will quickly produce the desired result. So our answer here is option C. So we'll mark it and we proceed to question number 26. Question 26. The length and breadth of a cuboid are 15 centimeter and 8 centimeter respectively. If the volume of the cuboid is 1,560 cubic centimeter, calculate the total surface area. Now, the total surface area, let's call it TSA. The total surface area of a cuboid is given as 2 into length times breadth plus length times height plus breadth times height. Now, let's go and mark what we have here. From what we are given here, we are told that the length is 15. So let's take this to be the length, 15, that is from here to this place. Now, let's take here from this place to this place. Let's take it as the breadth. Let's say we have the breadth here, and the breadth is 8 centimeters. Now, we do not know the height, so that this is the height. Now, the volume is 1,560, and you know that volume of a cuboid volume of a cuboid is given at length times breadth times height. So here we have 15 length times 8 times height equals 1560. And this will give 120 here. 1560. So edge, if we divide both sides by 120, we are going to have 1560 over 120. And if you use your calculator, which is allowed here, you get 13 centimeters, and that will be our height. So we have 13 centimeters. Now we can go on and put everything here to get the TSA, to get the total surface area, since we know all the three dimensions. So we said here that the total surface area, that is the TSA, is going to be 2 into length times breadth, that is 15 times 8, plus length times height, 15 times 13, plus breadth times height, 8 times 13. So this TSA is going to be 2. Of course, if you look at what we have there, it's going to give us 2 times 4, 419. So we have 2 times 419. And this is going to give us 838 square centimeters. And that is option B. That's option B. So mark it, and that's correct. So we proceed to question number 27. Now, here they say the number 1621 was subtracted from 6244 in base S. If the result was 4323, find S. Now, if you look at the biggest digit here is 6. That means the value of S as a base is going to be number greater than 6, of course. So we expect that our S is going to be either 7, 8, 9, or probably 10. So now, with this in mind, let's go on. We are told that from 6244, we subtracted 1621 to get 4, to get this value 4323. So now, this, let's not forget that this is in base X, this is equally in base X, and then this result here is also in base S. Now, 4 minus 1 is 3, correct? 4 minus 2 is 2, correct? Now, if we pick 7, supposing S is base is 7, the value of S is 7, we are making an assumption here. Now, if you collect 1 here from this quantity, this will drop to 5, and you call that one 7. If you add 7 to 9 to 2, you are going to get 9. 9 minus 6 is 3. 5 minus 1 is 4, obviously. Now, S equals 7, satisfy that condition. If you pick 8 and you do the same thing, borrow 1 from here, and then call it 8, that quantity becomes 8 because this is base 8. And you have 8 plus 2, 10. 10 minus 6 is not 3. So you see that 8 has failed. If you take 9, you borrow 9 here. If you borrow 1 and call it 9, 9 plus 2, 11. 11 minus 6 is not 3. This one has failed. If you do the same thing with 10, if you borrow here, that's 10 plus 2, 12. 12 minus 6 is also not 3. So this has failed. You see that this is the only one that satisfies our condition. So option A is the correct option. Like I said, you don't need to start expanding, getting a polynomial up to degree 3 and doing all kind of things. Of course, if you do that, you are still going to get 7 as your base, but it's a whole lot of long process. Just understand that the base is going to be a step above the biggest digit that form the numbers. So once you have that understanding, you'll be able to, things like this, you'll be able to do a quick test to pick out your answer and proceed to the next question and save yourself time. If you find value here, subscribe, click like, comment on the comment section, share this video, and others can get it. Let's proceed to question number 28. Question number 28, factorize completely 27x squared minus 48y squared. Now, let's look at this. This is 27x squared minus 48y squared. So here, from 27, we are going to get perfect square, which is 9 is a perfect square here out of the factors of 27. So we can look at using 3 times 9 will give us 27. We have s squared here. We can get 16 as a perfect square here. So if we use 3 times 16, of course, a perfect square is a number that has square root. Now 3 is common, so we can factor 3 out. And then open a bracket, we have 9x squared minus 16y squared. So coming here again, we are going to apply difference of 2 squared. Then we have this is equal to 3. Of course, 9 is the same thing as, 9s squared is the same thing as 3s raised to power 2. These 2 outside, we have fed both 3 and s. So when it operates on 3, it's going to give us 9, and here it will give us s squared. The same way, we are going to have 4y, then r squared here. So now, this is going to be 3 bracket 3x plus 4y, then 3x minus 4y. Note, this is the principle I use, or the rule that I use to get this. The rule said, when you have x squared minus y squared, we actually give you x plus y, x minus y. Okay, so this is what I use. It's called difference of 2 squares. So with this now, you will check to be able to see 3 into 3s plus 4y. Again, another bracket, 3s minus 4y. Look at this. 3 into 3s plus 4y, close bracket, another bracket, 3s minus 4y. Option B is the correct option. So we'll proceed to question number 29. For what values of s is s minus 3 over 4 plus s plus 1 over 8 greater than or equal to 2? Now we have x minus 3 over 4 plus x plus 1 over 8 greater than or equal to 2. Now we need to clear this fraction using the LCM. Of course, the LCM here is 8. 4 can also go in 8. So multiply each term by 8. So what you have here is this plus multiply this by 8. This s plus 1 all over 8. Multiply this by 8. Beautiful. Now let's clear what we have here. 4 can go here 1. 4 can go in 8, 2. So we have 2 into x minus 3. Of course, 8, we cancel 8 here. So we have plus x plus 1 greater than or equal to, this is 16. So open bracket, you have 2x minus 6 plus x plus 1 is greater than or equal to 16. Now, collect line terms, of course, add up here. 2x plus s is 3x, minus 6 plus 1 is minus 5. So let's collect like terms now. We have 3x is greater than or equal to 16 plus 5. 3x is greater than or equal to 21. So divide both sides by 3. S is greater than or equal to 21 all over 3. All right. So finally, what do you have? Finally, we have x is greater than or equal to 7. And then which option is that? That's option C. We mark option C and we proceed to the last question, which is question number 30. Question 30. In the diagram, angle SQR is 52 and angle ERT is 16. Find the value of the angle marked Y. So this angle marked Y is what we are looking for. This is 52 and this is a straight line. Don't forget, the sum of angles on a straight line is 180 degrees. So I can find this angle inside here. So all I need to do for me to find this angle marked red, I'm going to do 180 degree, 180 degree. Okay, move this. Okay, so I'm going to do 180 degree minus 52 degrees, and that will give me 128 degrees. So this angle here is 128 degrees. All right. Now this angle, if you note, look at this, there's a touch here, touch on the circumference, touch on the circumference 4 times. So this is a cyclic quadrilateral. And then the theorem here, there's a theorem that relates opposite angles of a cyclic quadrilateral. And the theorem says that the opposite angles, the sum of the opposite angles of a cyclic quadrilateral is supplementary. Or in another way, the sum of the opposite angles of a cyclic quadrilateral add up to 180 degrees. So it means also, if I want to find the value of this angle here, the value of this angle here, I am going to do 180 minus 28. Let me mark that angle with a different color. Okay. Let me mark it with a different color now. Let me mark it with blue. So if I want to get the value of this angle marked blue, I'm going to say 180 degree minus 128 degrees, and that will give me 52 degrees. So this angle is 52. Now look at this. This is a whole triangle. This angle is 16. This angle is 52. This angle is Y. So in triangle, look at in triangle PRT, in triangle PRT, if we add y plus 52 degrees plus 16 degrees, it will give us 180 degrees. That's the sum of interior angles of this triangle PRT. And so I have y plus 52 degree plus 16 degree is going to give us 68 degrees. That is 180 degrees. So collect like terms, y is going to be 180 degrees minus 68 degrees, and that is 112. So the value of y is 112 degrees. So we'll go and mark that. That is option C. And this is how far we come to the end of this tutorial video. If you find it impactful, why not go on, subscribe to our channel so that you enjoy many more videos that we are going to publish. Click the notification bell, like, share this video so that other people, the YouTube algorithm, will be able to take it to many more students. And go to the comment section, tell us your view about this video. Tell us what you want us to do to improve the quality of our videos so that you will benefit and other students will also gain a lot from the tutorial video. So this is Maths Minded Academy. See you in our next class, where we'll be looking at solution to question number 31 to 40. Bye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the